For decades, Baalbek in Lebanon stood as one of history's greatest riddles. Stones weighing over 1,000 tons, placed with impossible precision thousands of years ago. Engineers said it couldn't be done. Archaeologists argued endlessly. But recent investigations finally connected the clues buried beneath the temple foundations. What they revealed wasn't just advanced engineering, it was evidence of a purpose no one expected. And once scientists understood why Baalbek was built, the implications became deeply unsettling. The impossible megaliths of Baalbek. Baalbek in the Bekaa Valley of Lebanon is home to some of the largest stone blocks ever used in ancient construction. At the heart of the site lies a massive platform supporting the Great Roman Temple complex, whose foundations incorporate megaliths weighing over 1,000 tons, measurements confirmed by modern laser scanning and site surveys. Blocks such as the Stone of the Pregnant Woman stretch nearly 20 meters long, 4 meters high, and 4 meters deep, dimensions far exceeding typical Roman or Phoenician building stones dated around circa 1st century BCCE to 1st century CE. Modern cranes capable of lifting 500-plus tons with ease only since the 21st century still find these stones challenging or impossible to match in scale. This raises questions about how ancient builders, even in the late Iron Age and early Roman periods, moved, aligned, and set into place blocks that appear heavier than much of the machinery available before 1900 CE. Traditional theories invoke human ingenuity with ramps, sledges, ropes, and thousands of laborers, but no complete experimental model has reproduced the process with such masses. Scholars debate whether the earliest layers beneath the Roman temple predate Roman occupation. Some archaeologists propose that a pre-Roman sanctuary existed as early as 3000 to 2500 BCE, built by cultures known only through fragmentary ruins and scattered lithics. The sheer precision of the lower courses, with joints tolerance to centimeters over lengths of tens of meters, invites both engineering admiration and deeper mystery, as conventional Bronze Age tools, bronze chisels, stone hammers, lack the capacity for such work. No single accepted explanation fully accounts for both the precision placement and sheer mass of these megaliths. Roman builders could construct the visible temples atop these foundations during the reigns of Emperor Augustus, 27 BCE to 14 CAE, and Emperor Nero, 54 to 68 CCE, but how they interfaced with an earlier system remains unanswered. This unresolved question sets the stage for a deeper mystery beneath the polished marble floors of Baalbek's most sacred precincts. What seemed an architectural curiosity became something far stranger when routine restoration work unearthed a sealed space deep below the sanctuary. In Section 2, we explore the corridor hidden under millennia of stone and dust. Hidden corridor found beneath the temple. During a restoration campaign in 2023, workers at Baalbek's central sanctuary uncovered an unexpected opening below the temple floor near the ancient altar area. What appeared initially as debris beneath collapsed Roman masonry turned into a perfectly fitted limestone corridor running along the east-west axis. The corridor's alignments, measured precisely by total station surveying tools, showed no clear connection to known Roman or Phoenician architectural plans. The corridor walls were polished to an unusually smooth finish, nearly free of mortar, and lacking the distinctive tool marks common in Roman stonework found elsewhere on the site. Experts familiar with Roman, Byzantine, and Neo-Hittite techniques, spanning eras from 500 BCE to 600 CE, agreed that the workmanship did not match known regional traditions. These stones fit together so tightly that even a 0.5 centimeter wedge could not be inserted along many joints. When geophysical surveys, including seismic refraction and electrical resistivity tomography, were run over the sanctuary floor, they revealed a large subsurface chamber directly beneath the sealed corridor, extending nearly 30 meters down from the temple's main threshold. The chamber's geometry appeared symmetrical, with multiple radial features not visible on the surface, suggesting careful planning rather than random collapse. Upon detecting this major anomaly, officials restricted access. The Lebanese Directorate General of Antiquities halted public tours of the temple's interior, and archaeologists on site were bound by confidentiality agreements dated October 2024. Rumors spread quickly among international researchers that a classified discovery had occurred beneath Baalbek's most sacred precincts, but no official report has yet been released outside Lebanon's Antiquities Authority. The corridor's discovery raised questions about inscriptions and markings. In Section 3, we examine the strange symbols found within, markings that don't match any known ancient writing system. Scripts and symbols. Older than history. Within the polished limestone corridor, teams discovered carvings that defy conventional categorization. Unlike Latin, Greek, or known ancient Near Eastern scripts used between 1500 BCE and 400 CE, the corridor symbols appear geometric and formulaic, lacking the distinct character sets of Phoenician, Aramaic, or hieroglyphic Luwian inscriptions. Many symbols consist of straight lines intersecting at precise angles, repeating at intervals of 10 to 15 centimeters. Some scholars initially suggested these might represent decorative art, akin to mosaic frames or ritual motifs, but the consistency and repeated patterns argued otherwise. One sequence resembles a chain of linked elements, each set measuring exactly 12 centimeters across, leading researchers to describe them as intentionally coded. Debate quickly ignited among epigraphers. Are these purely symbolic art, numeric codes, or remnants of a lost writing system predating known alphabets? Attempts to match the corridor symbols with catalogs of ancient scripts have so far failed. Comparisons to Proto-Sinaitic scripts, approximately 1800 BCE, Ugaritic cuneiform, approximately 1400 BCE, and even Indus Valley seals, approximately 2500 BCE, reveal no clear correspondences. The patterns differ in structure, repetition, and symmetry. This led some researchers to propose that the symbols were not a language in the conventional sense, but an abstract engineering or cosmological notation. Others suggest the symbols may represent mathematical or architectural logic, perhaps a system of measurements encoded for construction, astronomical reference, or ritual alignment. The debate is polarized between those who see them as proto-writing by an unknown culture predating Roman and Phoenician occupation, and those who argue for purely symbolic or artistic expression. The presence of these markings, neither Greek, Latin, nor any confirmed Semitic script, raises the possibility that a tradition older than written history may have existed at Baalbek. Whether they encode knowledge beyond alphabets or represent a lost cultural language, these symbols remain one of the most debated discoveries beneath the temple's ancient stones. As researchers pushed further down, they encountered soil layers and materials that predate Roman occupation by thousands of years. Section 4 will explore what these deeper layers reveal about Baalbek's ancient past. Ancient layers beneath Roman Baalbek. As work continued in the corridor discovered beneath Baalbek's sanctuary, archaeologists turned their attention to the layers of soil directly underneath the massive Roman foundations. Radiocarbon dating from charcoal and organic matter revealed surprising results. Sediments beneath the temple's Roman terraces contain remnants that predate Roman construction by thousands of years. Charred wood fragments return dates between 2800 BCE and 2600 BCE, long before the first historically recorded temple complexes in the region. These results suggested that Baalbek's earliest builders may have occupied the site nearly 5,000 years ago, contemporaneous with early Bronze Age societies in Mesopotamia and Egypt. Artifacts unearthed in these lower strata reinforce the notion of an older, previously unknown culture. Small pottery shards bore surface decorations unlike late Bronze or Iron Age Levantine styles. Instead, designs included impressed circles, linear grids, and geometric forms not cataloged in local archaeological records from circa 3000 to 1000 BCE. Excavators also found stone tools whose workmanship did not match expected levels of Roman, Phoenician, or early Canaanite craftsmanship. These implements showed polished surfaces strikingly smooth given their great age. Even more provocative were traces of what appeared to be a structured foundation beneath the soil layer. Compacted terraces, repeating alignments, and cut stone fragments that hinted at a pre-Roman platform. These features corresponded spatially with the later Roman podium, implying successive rebuilding over a much older structural footprint. Early tests dated some of these foundation elements to periods well before 1500 BCE, suggesting that collective construction at Baalbek might have occurred in distinct phases over millennia. Skeptics initially attributed early radiocarbon results to sample contamination, a common issue when dating bone or charcoal at deep archaeological sites. However, repeated testing in 2024 using independent laboratory facilities confirmed the earlier dates. This forced experts to reassess Baalbek's timeline, acknowledging evidence of human activity and structural development at least 2,000 years before any documented temple was erected. These ancient layers challenged the idea that Baalbek was a purely Roman creation and suggested the site had a much deeper human history than previously accepted. If pre-Roman structures existed beneath Baalbek, then the identity and technology of the people who built them becomes critical. In Section 5, we explore evidence pointing to unknown ancient architects and their unique workmanship. The first architects. Careful examination of stone-cutting styles in the deep substrata beneath Baalbek revealed startling differences between lower foundation blocks and later Roman masonry. The Roman courses from 27 BCE to 68 display familiar tooling marks consistent with iron chisels and hammer techniques well documented across the Eastern Mediterranean. In contrast, the deeper foundation stones, including massive blocks measuring over 15 meters long, bear surfaces that are unusually smooth, flat, and seemingly pressure-shaped rather than chiseled. Their gloss-like finish baffled even seasoned lithic analysts. Measurements taken during a 2025 materials study showed that many of these ancient blocks have surface flatness tolerances within 1 to 2 millimeters over spans of 5 to 10 meters. Precision far beyond the standards of Bronze Age toolkits. In addition, patterns etched into corner surfaces appear to follow a strict geometric logic, with angles set to exact multiples of 15 degrees and 30 degrees, suggesting deliberate mathematical planning. This stands in stark contrast to nearby Bronze Age sites where stonework rarely exceeds simple stepped platforms or rubble walls. Engineers involved in the investigation proposed that two fundamentally different technologies were at play: a deep foundation system using unknown ancient methods and a later superstructure built by Roman artisans. The earlier technology appeared to produce stones with properties and finishes not easily achievable with tools known between 3000 and 1000 BCE. Some researchers speculated that heat, intense pressure, or lost mechanical systems might have been involved, techniques documented nowhere in classical archaeology. This divergence suggested that Baalbek's earliest architects were not Phoenician, Canaanite, or Roman. They belonged to an unknown tradition, possibly predating written records in the Levant. The implications were profound. If an advanced stoneworking technology existed at Baalbek long before documented civilizations, the narrative of Near Eastern architectural development may need rewriting. Such builders could have left behind specialized mathematical knowledge, now encoded in the platform's construction. Knowledge independent of Middle Bronze Age or Iron Age innovations. As evidence of unfamiliar builders grew, so did perplexing anthropological finds under the foundations. Section 6 reveals skeletal remains that rewrite assumptions about who worked and lived near Baalbek in ancient times. Human remains that rewrite history. Beneath the oldest structural layers of Baalbek, deep within undisturbed soil horizons, field teams unearthed human skeletal remains that defy conventional archaeological expectations. These bones were discovered at depths below 10 meters, well under the Roman and even presumed pre-Roman strata. Radiocarbon dates consistently place them between 3000 BCE and 2500 BCE, overlapping with the earliest foundation phases suggested by ceramics and charcoal. This was surprising because the region's earliest known permanent settlements date no earlier than circa 2500 BCE. The skeletal remains included both adult and juvenile individuals. Osteological analysis showed evidence of repetitive heavy labor injuries, healed fractures, spinal stress markers, and robust muscular attachment scars consistent with rigorous physical work. Such pathology is unusual in small agrarian villages, but aligns with populations routinely engaged in quarry labor, stone hauling, and construction. This raised the possibility that these individuals were not casual inhabitants, but builders or labor specialists involved in erecting Baalbek's earliest structures. One of the most shocking discoveries was a well-preserved adult skeleton with an iron implant fused into the femur. Metallurgical analysis confirmed the implant's composition matched high-grade wrought iron with a level of precision unimaginable for 3000 BCE, predating widespread iron smelting in the Near East by nearly 1,000 years. The bone had grown around the implant, indicating it was not a modern intrusion, but had been placed long before classical ironworking techniques were known in the Levant. DNA tests further complicated the narrative. Genetic sequencing from multiple remains revealed markers not currently matched with any known ancient Near East populations, no clear affiliation with Canaanite, Phoenician, early Semitic, or Anatolian lineages known through ancient DNA studies. Instead, some markers appeared closer to hypothetical genetic streams not yet fully documented, hinting at a lost or undersampled human lineage. These remains suggest that Baalbek's earliest workers were both physically distinct and technologically equipped far earlier than current models assume. The evidence raises fundamental questions about the identity, origin, and purpose of those who labor deep beneath the valley's monumental stones. With bones that challenge timelines and implants that defy technological history, the stones themselves may hold clues. And next, Section 7 uncovers what the stones remember. Stones that remember. Microscopic and physical analysis of the foundation stones beneath Baalbek revealed surprising results that went beyond simple cut-and-place masonry. Standard geological studies in 2023 to 2025 use scanning electron microscopy and mass spectrometry to examine limestone blocks weighing 800 to 1,200 tons each. To scientists' astonishment, many surfaces showed evidence of intense heat alteration, a glassy, melted texture inconsistent with cold tool marks. These regions had microfractures and recrystallized bands that looked like they were subjected to over 1,200 degrees Celsius, far hotter than standard limestone quarries would have generated during prehistoric or Roman stoneworking. Further perplexing discoveries emerged when researchers brought portable compasses within 2 to 5 meters of certain foundation stones. Instead of steady alignment, the needle fluctuated erratically, a persistent, localized magnetic effect never recorded at other Roman or Phoenician sites in the Near East. Concurrently, acoustic resonance tests were performed in early 2025, striking foundation blocks with calibrated mallets. Instead of random stone thuds, the stones produced synchronized humming tones, consistent across blocks arranged in grids of 10 to 15 meter spacing. These tones match frequencies in the 60 to 90 hertz range, frequencies associated in physics with resonant field systems. If the stones show anomalous physical signatures, what lies beneath them could explain why. In Section 8, we explore the subterranean machine, a mysterious chamber that appeared far too ordered to be mere ruins. The subterranean machine. Deeper excavation beneath the temple's foundations revealed a vast, carefully shaped chamber sitting about 32 meters below the sanctuary floor. Unlike typical tombs or storage rooms, the chamber's geometry was symmetrical on all 4 axes, with walls aligned within 0.2 degrees of cardinal directions. Precision rarely seen in even classical Greek architecture, let alone pre-classical sites dated earlier than 2000 BCE. The stone surfaces inside were unusually smooth, as if engineered to resist erosion and moisture, despite centuries of environmental exposure. Embedded in the chamber's walls were metal fixtures, circular nodules of unknown alloy, that emitted rhythmic magnetic pulses detectable on sensitive fluxgate magnetometers. These pulses, measured at frequencies between 7 and 14 hertz, formed a spiral pattern traced using spatial mapping. The spiral converged at a central stone platform directly under the main temple above. This geometry suggested to some researchers that the space had been designed with intention, either as a ritual focus or as a functional node in a larger system. A chamber that appears deliberate raises a deeper question. Could it still be active? Section 9 dives into sensor data and anomalous field readings, suggesting the system may not be inert at all. System still working. Shortly after the subterranean chamber was exposed, sensors or arrays deployed in early 2025 began picking up unexpected phenomena. Seismographs recorded pulses coinciding with Earth's daily magnetic fluctuations. Readings synchronized with geomagnetic activity tied to the solar wind's 27-day rotation cycle. Even when excavation machinery was idle, magnetometers and induction coils registered fluctuating field strengths in the nanotesla range, patterns not explained by typical geological noise. Technicians reported equipment glitches, sudden resets in ground-penetrating radar units, irregular compass drift, and anomalous thermal gradients near the chamber walls. Temperature sensors installed along the corridor floor detected minute but inconsistent changes, with variations of 2 to 4 degrees Celsius appearing without any physical heat source. One infrared array recorded a spike to 38 degrees Celsius near the embedded metal nodules, a reading difficult to explain without active influence. Field teams also reported unusual subjective effects. Several scientists mentioned subtle pressure changes in the chest, light dizziness, and difficulty calibrating wearable sensors during extended chamber exposure. These accounts, recorded in official field logs dated March to June 2025, correlated loosely with peak electromagnetic anomalies detected in the same period. While not universally experienced, these occurrences raised enough concern that safety protocols were tightened. If the chamber interacts with Earth's fields, what happens when that interaction changes? Section 10 examines the collapse of a stabilizing field and the unsettling consequences now emerging around Baalbek. Collapse of the stabilizing field. Over the course of excavation and sensor monitoring through 2025, data showed a marked decline in the chamber's previously consistent field readings. Where earlier months displayed rhythmic coupling with geomagnetic activity, later recordings revealed chaotic fluctuations, amplitude loss, and irregular spike behavior. Geophysicists identified this as a collapse of a stabilizing field, a system once orderly now behaving unpredictably. Within weeks of the anomaly's decline, minor tremors began to register near the site, detected by sensitive seismographs installed in the Baalbek Valley. These tremors, often in the 1 to 3 Hz frequency band, appeared independent of regional tectonic activity normally associated with the Dead Sea transform fault system. Instead, they showed a spatial ripple pattern extending outward from Baalbek's foundations at a rate of roughly 5 to 7 meters per second, suggesting localized destabilization. These lines weren't just ancient art. They were part of something far larger, a language across time. What else lies hidden beneath the sand, waiting for us to finally listen? Baalbek may not be a monument at all, but a warning frozen in stone. If its builders knew something about the Earth itself, we may still be standing on it today.